With this short video, I would like to show you the setup of a topology optimization task for Tosca structure using Abaqus CAE. First, we have to load our model, which should be available as Abaqus input deck. In the next step, we would check our loads and boundary conditions for completeness. Here in this case, we deal with the control arm, which is loaded here in the lower part, and realized as half model using boundary conditions. Now we can already set up our optimization task, either using the optimization module here in the module menu, or creating a new optimization task in the task manager. We will create a topology optimization task to maximize the stiffness of our design. First, we have to choose our design area, which consists of all elements which are allowed for modification. Then we choose the condition-based optimization algorithm, which is the simplest algorithm available. In the next step, we will define our design responses used to characterize the optimum, the strain energy of the whole model as measured for the stiffness, and the volume of the complete model as value for later use in a constraint. So now we can already define our objective function. We will minimize the strain energy, which is equivalent to a maximization of the stiffness, and we will assign here the predefined design response to our objective function. For the definition of the volume constraint, we also assign our predefined design response to the constraint, and we choose here a fraction of 0.7 corresponding to 70% of the original volume as target volume. Now let us create geometric restrictions which can be used to define manufacturing constraint. For example, a demold control also applied to the design element area, and now we will define the demolding vector using 2 points at the beginning and the end of the vector. So now our complete optimization task is defined, and we can check our definitions finally and set up the optimization process. This optimization process is controlled by certain parameters, for example, the maximum number of cycles, which can be set here in this menu. And once everything is in place, we will submit this process as usual, and the optimization will run in batch automatically. Now let me show you how to post-process your optimization results. Once your topology optimization is completed, there are several result files available for each optimization iteration, and you have to combine them to one single ODB file for easy post-processing. Choose all optimization cycles and the results you're interested in. The Tosca optimization results are pre-selected already. Then the combination takes place, and now you can switch to result visualization and post-process your results as normal in Abaqus CAE. You would probably have a look at the material property distribution during the single optimization steps. You can switch on and off the soft elements. That means they are hidden from the model here in the view. And finally, you can also extract this result to an Abaqus input deck, for example. This is done using the extraction procedure here. You choose an ISO value because the extraction cuts the original model at the border between soft and hard elements, between the elements with the original density and the elements with nearly no density, and the ISO value determines the border where the model is cut. After the model is extracted, you can load the input deck, for example, to Abaqus CAE and visualize it here, or reassign the original loads and boundary conditions and perform a validation run of this design proposal, or also use this design proposal for further processing in a CAD system.